TAI Anka first entered the Turkish military's inventory in 2016 following the successful testing of a prototype in 2013. The drone can conduct a range of missions such as real-time intelligence, surveillance and reconnaissance, communication relay, target acquisition, and tracking. Anka's composite structure integrates a locally developed, fully autonomous flight control computer to provide autonomous waypoint navigation and flight control. The autonomous system also enables the UAV to automatically return to the predefined location in the event of loss of communication with the ground control station. The synthetic aperture radar (SAR) and inverse SAR (ISAR) and a ground-moving target indicator radar on board the UAV are used to detect, identify and track stationary or moving ground targets. The Anka-S variant is fitted with a modified radome structure incorporating a high-power Viasat VR-18C airborne satellite communications antenna, which provides secure, high-speed, beyond line-of-sight communications. With a payload capacity of 200 kilograms, the Anka-S platform can carry a range of mission-specific payloads. The Anka-S has two underwing weapon stations, which can carry weapons such as the Roketsan Smart Micro-Munitions Air-Launched Missile Launcher and the Sirat 2.75-inch Guided Rocket Pod to engage light armored vehicles, personnel, military shelters and ground radar stations. The TAI Anka is a family of unmanned aerial vehicles (UAV) developed by Turkish Aerospace Industries (TAI) for the requirements of the Turkish Armed Forces. The basic Anka-A is classified as a medium-altitude long-endurance male UAV. Envisioned in the early 2000s for tactical surveillance and reconnaissance missions, the Anka has now evolved into a modular platform with synthetic aperture radar, precise weapons and satellite communication. The drone is named after a phoenix-like mythological creature called Zumrud Anka, Anka Kusu in Turkish. The TUAV system consists of three air vehicles: AV, Ground Control Station, GCS, Ground Data Terminal, GDT, Automatic Takeoff, and Landing System, ATOLS, Transportable Image Exploitation System, TAIS, Remote Video Terminal, RVT, and various ground support equipment, GSE. The TUAV system, which is designed for night and day missions including adverse weather conditions, performs real-time image intelligence, surveillance, reconnaissance, moving, stationary target detection, recognition, identification, and tracking missions. While the TUAV system has an open architecture to support other potential payloads and missions, within the context of the existing project the air vehicle is configured to carry the following payloads on board: electro-optic color day camera (EO day TV), electro-optic, forward-looking infrared, laser rangefinder, laser designator and spotter camera, EO, FLIR, LRF, LDS, synthetic aperture radar, ground-moving target indicator, SAR, GMTI, inverse SAR, ISAR. The whole composite airframe is composed of a monoblock fuselage, detachable wing and V-tail, retractable landing gear, redundant control surfaces, avionics and payload bays and service doors. The sandwich skin structure is reinforced by composite or metallic frames, ribs, and supports. Propelled by a pusher-type heavy fuel engine, the aircraft is furnished with fuselage fuel tanks and fuel system, ice protection system, environmental control system, lighting system, redundant electrical system with battery backup, and harness system. The platform is also equipped with a digital flight control system, electromechanical actuators, and flight control sensor systems such as GPS, pitot static, air data computer, navigation sensor, transducers, temperature, pressure, displacement sensors, etc. Various tasks are distributed along flight management computers and auxiliary control boxes. Identification and communication units and interface computers are employed in order to establish real-time wideband communication and provide test and diagnostics functions. An air traffic radio is also integrated in the communication system for the integration of the aircraft into the civilian airspace. All flight critical equipment are dual or triple redundant and emergency modes of operational scenarios are taken into consideration for fail-safe design. All airborne and ground-based flight control software is developed by TAI while payload and other relevant hardware and software items are aimed to be developed by national subcontractors, such as Aselsan, AYESAS, and Milsoft. UAV operations are supported by highly sophisticated ground control system with complete redundancy, developed by a domestic defense company Savronic. Whole mission segments of the air vehicle can be managed, monitored and controlled by a GCS. A pre-programmed mission plan can be loaded before the flight begins or can be altered during the flight. All the imagery stream of the payloads can be displayed and recorded in real time, and all the payloads can be controlled from the GCS. ATOLS allows the air vehicle to perform its operation without operator intervention, including the most critical phases, which are landing and takeoff. In TAIs, valuable intelligence information can be obtained by the analysis of bulky imagery data. TAIs operators can initiate intelligence missions prior to or during flight. Refined information flows to the upper command layer in order to assist the headquarters to monitor a network of TUAV systems and benefit from the gathered intelligence information. Another interface of the TUAV system is the RVT, with which other friendly units who are close to the target area can utilize the real-time imagery that TUAV air vehicle broadcasts. Anka-S is a serial production configuration of Anka. It is equipped with Viasat's VR-18C high-power SATCOM antenna and a national flight control computer. Like Block A and Block B, Anka-S will be powered by Thielert Centurion 2.0s. On the other hand, Turkish Engine Industries TAI has been developing a national engine, capable of running with diesel and JP8 jet fuel. On the 25th of October 2013, Turkish Undersecretariat for Defense Industry (SSM) ordered 10 Anka-S UAVs and 12 ground control stations for $290 million, $220.6 million plus TRI $137 million. The UAVs would be delivered in 3 batches, 2+4+4. The first batch was planned to be delivered in March 2017. A total of 6 aircraft were planned to be delivered in 2017. In 2016, media reported that the TAI was manufacturing 4 Anka-S UAVs for the armed forces. The first 2 of these aircraft were to be equipped with Starfire 380 HDL FLIR payload. However, these would be replaced with Aselsan CATs later on. On the 17th of August 2018, Directorate for Defense Industries announced that the Anka-S completed its first live fire tests. The platform was tested with MAM-L ammunition developed by the Roketsan. In September, Ismail Demir, director of the Turkey's Defense Industry Authority, shared a picture of the first Anka-S equipped with Aselsan CAT's optical system. TAI delivered 2 more Anka-S to Turkish Air Force in September 2018, increasing the Anka-S inventory of Turkish Air Force to 8 aircraft. TAI is planning to deliver a total of 10 Anka-S to Turkish Air Force before 2019. In August 2018, the Anka-S carried out Turkey's first satellite-controlled airstrike. In December, an Anka completed its first flight with an engine produced domestically. In 2019, the Anka broke its endurance records, flying longer than 24 hours. Although Ankas have an operational range of about 100 miles, the Anka-S, satellite-enabled, is capable of flying beyond line of sight.